Post-quantum cryptography is necessary, but it is not sufficient. Most of crypto is preparing for the threat they can clearly see, which is quantum, but there is a second threat vector that market is still underpricing. That would be AI-accelerated mathematical breakthroughs. If AI can help discover new classical algorithms against the structured mathematics that we are using in today's signatures, the industry can face a cryptographic shock before large-scale quantum computer hardware becomes practical. So that's why the real migration is not just post-quantum. It is post-quantum and post-AI cryptography. It means that cryptography of today that we use in crypto is basically obsolete. So that is exactly why EternaX exists. So I'm Dariia, CEO and cryptographer at EternaX, and today I have Pars with me who's going to ask all the hard questions. We are going to cover why elliptic curve cryptography is a big long-term risk, why existing post-quantum cryptography is not the end of the story, how recent quantum research is making the risks much closer, and why EternaX is building a different model. If you are building in blockchain, stablecoins, RWAs, wallets, exchanges, or any AI-driven finance, this conversation matters now.
Thanks for this long introduction, Dariia, and an introduction of the podcast. I think this is essentially what you're trying to say is that AI can also break elliptic curves, and which you will cover in this podcast. And so there is a threat, right, on double sides of AI math, and the second is post-quantum. So if there is any solution which is essentially covering both the threats, that is the path forward for any individual who is even spending $1 on chain. It does not matter you have $1 or $1,000 or $10,000 million. They can be stolen if they are not PQ safe. And if they can be stolen, then they are actually zero. So let's start with the headline, Dariia. What exactly do you mean that post-quantum is not enough? What does that exactly mean?
Right, so that is the title of the blog that we recently published, Why Post-Quantum is Not Enough. And it's something very, very specific. So the industry's default stance right now is that current crypto depends on elliptic curves and quantum can break those assumptions. That is true, so everybody wants to migrate to post-quantum schemes and close the problem. That is correct, but it's only half correct. Because a big class of post-quantum schemes are still built kind of on the same category of hardness assumptions of certain problems. So in plain English, that would be that people believe that this math problem stays hard because it has stayed hard for decades and all the people who looked at it could not solve it. That means that the risk does not disappear, it just changes form. So post-quantum is necessary, but it may not be enough for the breakthroughs that are done by intelligence that far outpaces the intelligence of people that have been working on these problems up to today. So if the skill still depends on the structured mathematics to stay hard forever, it cannot be the final migration.
Okay, I mean, this is something, Dariia, this reminds me of my math class, when I thought, I might have solved the, toughest problem. And I used to feel very, very excited that I have been able to solve that. But then there used to be another big problem, which, possibly I couldn't do that. But there was a senior in my school who could do that. So I think, and I always felt stupid, at that time, because I thought I was the genius there, but there was already, some other individual. And that some other genius now in my world of crypto is going to be AI, which is going to crack the math problem, which, possibly not the experts were able to do so far, but possibly it can, and what we have been seeing is that AI can do things which people thought were not possible. We have heard most people, saying that crypto breaks and think only about quantum, and you are putting AI into the same threat model, right? Why can it break that? And would you want to highlight, why AI math is also a threat model?
Right, because real vulnerability right now to crypto is not just quantum, is that the kind of existing cryptography is getting obsolete. So if you have to migrate, you might as well consider all the threats already. And people have different opinions on when quantum computer can come. And people have different opinions whether AI is able to do the math right now to break cryptography. But we are talking on the timeline, 5 years, 10 years, 15 years. Let's say you migrate to quantum cryptography, but are you willing to bet that AI is also not going to be able to break it in like 15 years, even if we're not saying now? So the real vulnerability of cryptography is not just quantum, it's its structured mathematical foundation. If there is a breakthrough in either quantum or AI solving that mass, it breaks in both cases. So for decades, we have been saying in the industry that a problem is secure because hundreds of brilliant mathematicians all over the world in all the universities have looked at it and they tried and they failed to find a fast attack. So that security's intuition has been built on the decades in the world where the search process was just human brains. It was bottlenecked by human resources of all these research universities, the salaries that they paid to these people, and the small amount of people, which is a very small percentage of the world, who is able to do the math on that level. That has now changed. AI is becoming a force multiplier in mathematical exploration. You may be willing to argue it's not able to do these things on its own yet, but if you give existing researchers who have this experience and who have this understanding and know what they're looking for, this speed up, they will be able to go much, much faster. So the old statement that we have believed that if no one has found an attack is not providing comfort anymore like it used to be. It creates basically a second clock. One would be quantum and the other one would be AI algorithmic discovery. Justin Rake has brought this up on Unchained podcast a couple of weeks ago, that this is not only a move to post-quantum cryptography that all of the industry has to make, but also a move post-AI cryptography, and we are going to discuss exactly what that means. That would be a real strategic shift that people have to think about. A quantum break will probably arrive through like some visible compounding engineering progress, with research papers coming out every week now. But classical algorithmic break can arrive in a single paper overnight that is going to just compress the migration timeline.
Got it, Dariia. I think this brings me to one analogy where I saw a monkey once roller skating, and possibly that monkey was very famous within his community of monkeys that he's one of the geniuses who can roller skate, and for us it's a thing of amusement. So I think what you're trying to say is that AI is humans in this case, and we are the monkeys. So if AI does some mathematical improvements which kind of breaks the elliptic curves, the things are almost done. So I mean that's a real security threat, and we don't know when this will happen. We can't predict when it will happen. So makes sense, Dariia. Let's move on to the next section. Let's get down to the controversial point, Dariia. You have been mentioning in your blog that Dilithium and Falcon, which people treat as post-quantum answer, still carry the same broad category risk of AI math threat. So, I mean, a lot of chains, a lot of infrastructure projects are looking at Dilithium and Falcon as, NIST approved schemes for PQ. Can you explain clearly, Dariia, what is happening here?
Yes, I have been saying that, but it has to be stated very nuanced and precisely, so you should read the full blog to understand all of the nuance. I'm not saying that Dilithium or Falcon are broken. They are still like NIST approved post-quantum signatures, but they are computational schemes built on the hardness assumptions that we have just discussed. It's very structured algebra called lattices, and that matters because the security that depends on a structured mathematical object means there can be future algorithms that could potentially exploit that structure. And there have been many examples of the signatures that did not make the standard. They look structured, they look secure, but somebody has found a flaw and AI will be able to find the flaws faster. So the same category of concern that exists in the elliptic curves, they are structured algebraic objects. So one honest framing of this would be that Dilithium and Falcon solve the known quantum threat that exists in elliptic curves, but they still do not eliminate the broader risk of an algorithmic discovery that is going to break their algebraic structure. So in a world when AI can accelerate researchers in their mathematical research, The right line would be that Dilithium and Falcon are strong post-quantum steps, but they're not post-assumption. They're not unconditional security, and that is a big distinction.
Got it. I think this distinction is important, Dariia, that you're saying one is post assumption cryptography, and Dilithium and Falcon do not meet that requirement. So essentially, what you need in times of today is a post assumption cryptography, which kind of meets the threats of both AI maths and post quantum improvements. So this distinction is very important for individuals to and listeners to understand, because this is the base of the security at EternaX. So moving on to the next chapter, Dariia, like I understand there are three schemes that have been approved by NIST. One is Falcon, Dilithium, and the other is Sphinx. Why not then just use Sphinx and call it a day, Dariia?
I mean, you're right. Yes, Sphinx is a lot more conservative, but like it has its own trade-offs. So Sphinx, on the difference to Dilithium and Falcon, is a hash-based signature. And it is much more conservative because a hash does not have algebraic structure that defined as elliptic curves on lattice-based systems. So hash basically behaves pretty closely to like a random oracle. So that's why many cryptographers treat them as a much safer option. So it depends on the same assumptions that the hash functions depend on, that which is like it has to be one way, it has to be collision resistant. But the main problem with it is size. So the hashes as the fingerprints of data are very, very small, but hash-based signatures have lots of hashes in one signature, and they're much larger than the data itself. That is a very, very big issue for blockchains. So this makes Sphinx usable in maybe other applications where you just have to like exchange keys once. But if you have to carry them in all of the blocks for all of the transactions, it's very, very heavy. So it does improve the security, but it kills your performance.
Okay, so basically what you're trying to say is that just to keep my car safe, I have to buy a junk which nobody wants to steal. I mean, essentially, if there is something which is so low on TPS, it's not even worth operating on. Essentially, it's just not worth working on. And if somebody is using Sphinx as their PQ scheme, the TPS loss would be horrendous. And I mean, if I remember correctly, the hash sizes are somewhere around 7,800 bytes, which is like somewhere around 8 kilobytes.
Right. So signing blockchain transactions with Sphinx would be like driving around the city in a tank.
Yeah.
You are safe,
yeah,
but you're slow.
Yeah. And basically you want to go to shopping, but you have a tank. So I mean there's a lot of inconvenience. And so I mean the analogy for the blockchain environment would be you want to trade in milliseconds, but the wait time and the TPS is like 15 minutes, 20 minutes, whatever. So I mean, just does not make sense. Cool, Dariia. This makes a lot of sense and settles the case for Sphinx. But a lot of people still talk about quantum risk like it is far away. And I know there is a latest research that just came in today, and we were fortunate enough to get a hold of it. Would you like to, just highlight what they have said there?
Right. I think there's people who underestimate it, just don't keep up with research, and it's a lot to keep up with. There's new breakthroughs coming out every week. So last week we discussed about the Pinnacle architecture that decreases breaking RSA to 100,000 physical qubits. Same last week, another paper came out from French University of Rennes that talks about specifically quantum discrete logarithm solving over elliptic curves. And it pushes the resource estimate from previous paper down 2x more. So if you want to take the elliptic curves on which are like Bitcoin and Ethereum and all the ones are built on, the previous estimate was that you were going to need 2000 logical qubits. This new paper shows 1098 is enough. So that's a 2x just in this week. So the trade-off there is in the architecture about you need more gates to achieve those qubits, but it's still attainable. So the message is not that, elliptic cryptography is going to break like tomorrow. But the message is that like the qubit assumptions and the algorithmic improvements are converging. and they're getting very, very close to each other. So every time every new paper comes out and pushes the research threshold downward, or some hardware improvement pushes the amount of qubits that we can achieve upward, they start converging, and the comfortable margin around elliptic curves gets smaller and smaller, basically every month this year. So the risk is not that quantum has already arrived. The risk is that cost curve is not favorable to the speed of crypto projects moving out of elliptic curves, and they are pretty slow.
Makes sense, Dariia. I think the whole idea is that, I think last week I remember we discussed about, the reduction was 10x within 1 year, and within 1 week we are seeing 2x reduction again. And this says something about the space. This says something that the intelligence somehow has increased in the world today. I don't know how that is happening, probably AI, but the intelligence has increased in the space, and things are coming in, serious things are coming in more often than before. And I don't think that there is a way that we can slow it down. And as I told you, we are the, monkeys on roller skates right now. So it's better that these monkeys, better understand that their crypto needs a better security right now, and not 1 year down the line or 2 year down the line. And especially not 7 year down the line when Bitcoin thinks of, they can migrate. So the risk curve is moving, Dariia. What should institutions and infrastructure teams do now? Essentially, like, what should be their next step?
They should start moving, and they should stop treating migration as some last minute switch pull. It is a timeline problem. It's architecture, it's testing, it changes protocol dynamics. There is rollout, there is interoperability through the whole ecosystem. That's wallets, that's custodies, that's exchanges. Users have to move their money, each single user individually. That's a lot of things that need to be all done correctly. NIST has already made their stance very, very clear for institutions and federal agencies in the United States. They have said you have to start integrating now, because full migration takes time, and their deadline is in 3 years. And for institutions, that's a very, very short time. So the right framing is to start moving. Migration is not a switch. You cannot flip it in a panic, because even if you panic and put a post-quantum signature, you'll probably implement it wrong and it's going to break anyway. It is a multi-year problem, and it matters even more than the target is not just more secure, but potentially much heavier in bytes, in validation costs, in operational complexity, in paying for gas, and all of that.
So the basic solution, Dariia, what I see is just why bother about migration? Why bother about the TPS loss? Why take all those pains? Why not just mint day one native with us? Because once you mint day one native with us, you are PQ safe day one with EternaX, and you don't have to bother about all these debts. You just can be happy and look at the business side of things. I am sure OCC is not making the stablecoin world really easy for those guys, and there's a lot of things that they need to concentrate on the business side of things. So why take on one more problem? So it's my request to all these institutions, get in touch with us. We our contact would be in the description. If you are an issuer of a stable coin or an RWA currently, please, we request, consider minting PQ native day one, rather than getting all these debts. Because either you tell me that the date when AI math will be broken, and the date when post quantum will be broken. If you know these two dates, you are good to go. If you know these, you're good. If not, then I think you need to stick with EternaX. So moving on to the next question, Dariia. So if post quantum is necessary, but still assumption based and hash based is conservative but heavy, what is the EternaX alternative? Why EternaX? Why are we even discussing all these things? So where does EternaX shine in the space?
Right, so the stance that we have taken is do it well the first time. So you don't have to migrate, you don't have to redesign your protocol every 2 years. So we are building around an information theoretic signature model. The core idea of it is simple. When a user submits a transaction, that interaction happens over a channel from the user browser to a validator or an RPC endpoint. So we use that channel context as a part of the transaction authentication design, given that TLS already supports quantum, that allows the validator to verify a signature that's very, very small and much smaller than existing alternatives. So the key difference is the security class of the signature. So elliptic curve and lattices are based on like algebraic computational hardness assumption. Sphinx is based on hash, so that's random oracle assumption. Information theoretic signature instead are based on unconditional security assumptions. That means that the unforgeability is not designed to like reduce to some standard computation problem like elliptic curves or lattices. It's a totally different class. We remove that reliance on structured algebraic objects and we bet on the unforgeability of the signature in an information theoretical way. That basically means that the signature encodes a system of equations that has more unknowns than parameters. So it's impossible to solve it. It's not hard to solve it. It's impossible to solve it. So we are going to be releasing the full construction details in the paper that is currently pending publication and a separate architecture thesis of how that actually aligns with a blockchain protocol, but it allows us to achieve all of the boxes that nobody else has been able to do so far. So it makes signatures that are both post-quantum secure, do not have any algebraic structure that can be exploited by either human mathematicians or AIs, and 3, they're small in size, which makes them perfect for blockchain on comparison to like Sphinx. So you are not going to be riding in a tank anymore. You're going to be riding in a Tesla with like bulletproof windows.
Yeah, got it. That makes sense. Even if the users are difficult, the jargons are difficult for them to understand, one thing that the key takeaway from here is that you actually don't need to know how the lock operates, right? You just need to know that it is the best lock out there. And, people can't just break it. So once you know that, it's fine. You can move your attention to things that, okay, my things are safe, my crypto is safe, I can trade with that, I can use it as collateral and stuff. But if you are always worried that when will my crypto be stolen, I don't think so that you'll be the most productive guy in that space. That worry is what EternaX takes away. You don't have to worry about that. So thank you, Dariia, for putting that in that sense. But let's make this concrete for the builders. Why does the signature design matter so much for the blockchain performance?
Well, because signatures is like the most repeated cryptographic object in the entire blockchain. Every transaction carries one. Every consensus message carries one. They take block space, they take up network bandwidth, they take up propagation speed, verification cost that you have to pay for with gas. That cuts up the throughput ceiling and it basically bottlenecks the whole system if the signatures are large. So this is where making them smaller really becomes unavoidable. So for instance, Cloudflare said that security story and byte overhead story is the same, which means the more you have to put every byte on the signature, the more you have to still pay for it computationally and throughput wise. So for blockchains, that directly affects transaction costs, scalability, latencies. Any product or liquidity that can live on it has to now pay the throughput tax if you increase the signature size. So if your migration path just improves security of signatures, but basically materially bloats every transaction to the point of unpracticality, you have solved one risk by basically throttling your chain. So EternaX, we treat cryptography and market speed as the same design problem. They are not a trade-off like every other chain has to make.
I guess this makes a lot of sense, Dariia. This reminds me of the times of BlackBerry versus iPhone. When the iPhone first came, the iPhone was basically a complete screen and that complete touch screen. Also, the engineers were working on the applications and Apple Store and how to get the ecosystem and stuff, while BlackBerry was still working how to get the best trackpad. the nicest clicks. So I mean, still, this makes a lot of sense that we clear away the path and we solve for both the things simultaneously. From the first principles, when you think and design, this is what is the result, is cryptography at market speed. That makes a lot of sense. So there are no compromises here. And I think this is the best way and place to kind of live in terms of ecosystem. So let's come to the stablecoin issuers, Dariia, the RWA platforms and exchange operators. So today there is a lot of news that we have a 350 billion stablecoin market right now, and it is increasing day by day. So there's RWA platforms. Wisdom Tree got an exemption. There was a 2% haircut on the stablecoin as a collateral by the SEC in their guidance. There's a lot of positive news coming out there from the regulatory side of things. What are the considerations for these guys? What they should do? Because regulatory is solved for them, but this still is a big problem. So how should they think about it?
Right. They have to think about it actually much harder than regular users are, because they don't just hold $100 in a wallet. They are issuing authorization systems, basically. They're issuing liabilities today that carry migration debt. So every transfer, mint, burn, treasury move, custody control, workflow, transfer, liquidation, all of that depends on trust in the signature. And once the signature layer is fragile, your whole asset stack collapses. So when eventual migration paths explodes, size, latency, operational complexity, your asset can only remain secure in theory. Because in practice, it's commercially worse. If it's either insecure or if it's secure, it's slow and unusable. So the hidden cost is still underestimated in the market. The correct requirement for the next generation financial infrastructure is on which you would want to issue these assets that are multi-year lifespan, potentially decades lifespan, that it has to be quantum safe, it has to be AI resilient, it has to be practically and operationally scalable and fast enough for real market activity to which we have been used so far, indexes and perpetuals and all of that, and should not encode future migrations if possible. So that is exactly the decision tree that EternaX has designed around.
Got it, Dariia. So I mean, you're saying that the real requirement of the next generation financial infrastructure is it should be quantum safe, AI resilient, operationally scalable, fast enough for real markets, designed to avoid repeat migrations if possible. So I mean, that's what the EternaX is targeting at. And I would like to just close in on the last segment, Dariia, and this is like the fun segment where you tell the myths and the realities. So just break some myths, Dariia, in this segment, please.
Yeah, I can recap a few. So one would be that quantum is the only thing that matters. That's not true. AI accelerated research for mathematicians can compress even the classical breakthrough before quantum becomes a real threat. Two, going post-quantum cryptography means that the problem is solved. Not also true, because post-quantum schemes, some of them are still based on computational hardness bets that can be broken by research, by people or AI. Three means, we just select the most conservative and be final with it. Also not good, because hash-based signatures are reducing algebraic attack surface, but they are very operationally heavy. And then signature size is just an implementation detail is also not true, because it very directly translates to market infrastructure, latency, gas costs, all of the pain. So correct mental model would be to keep all of this in mind if you're designing a protocol. That's all you have to do.
Thank you, Dariia. Thank you. I'll quickly recap, what has been discussed in this podcast. So one line, what you people have to take away from this is post-quantum cryptography protects you from the computer you expect, and post-quantum assumption design protects you from the breakthrough you do not expect. I mean, you just have to be safe from every side, and that's what we kind of from the knowns and the unknowns both. I mean, this is where we are headed. We protect you from the knowns and the unknowns, and that's what the unconditional security comes from. So a quick recap of the podcast is that ECC is not a permanent foundation. Quantum is not the only threat. AI changes the threat model too. Dilithium and Falcon are important post-quantum steps, but they still live in the world of structured computation assumptions. And Sphinx is more conservative, but is still computational and operationally heavier. Recent research shows that quantum cost curve against ECC is moving, and with the lower logical qubit estimates, even when the gate cost remains, severe. EternaX thesis is simple, where the workflow allows it. Move towards the post-assumption transaction signing with information theoretic security without sacrificing market speed performance. Post-quantum is necessary, but post-quantum is not enough. So this is the thesis behind EternaX. We'll share the complete description. We'll share the contact us details. We'll look forward to in the next podcast. Thanks for listening to us. We really appreciate it.
And see you all in the next episodes of the Control Loop.
Thank you.